Welcome back, students. This is the Q&A session 14 from the playlist of electric charges in field. The topic is intensity of electric field, and this is the question which is available in the NCERT book. I have taken the question from the NCERT book, and the question here is: the two charges in the free space are placed at this point A and B, as shown in this figure. At the point A, there is a negative charge of magnitude 10 microcoulomb, and at the point B there is a positive charge of magnitude 10 microcoulomb, and both these two charges are separated from each other by a distance of 5 mm, because OA is equal to OB, which is equal to 2.5 mm. There is a point P in the free space, and when this point P is dividing this line, joining these two charges in two equal parts, when a perpendicular is drawn from that point on the line joining these two charges. So this is a perpendicular. OP is a perpendicular to the line AB, and the length of this OP, that is the length of the perpendicular from the point P on this line AB, is equal to 15 centimeter. Now OA is equal to OB, which is equal to 2.5 mm. This is in mm. Now we know that the question here is, we have to find the intensity of electric field at the point this P due to these two charges. So we know that for a negative charge, the electric field lines are directed inwards, that is towards the charge, and for a positive charge, the electric field lines are directed away from the charge. So that so I have already drawn here the direction of the electric field due to these two charges. So due to this positive charge, the field line will be directed outward, as indicated by this arrow, because from a positive charge, the direction of the field lines are directed outward. So it will be, the field lines will be directed along this line, along BP, and the direction will be as given by this arrow. Since the at this point A there is a negative charge, now in the case of the negative charge, the electric field lines are directed inward, as shown here. So in this case, at this point P, due to this negative charge, the field lines will be directed inward, that is towards the charge, and here I have already drawn the direction of the electric field due to this negative charge, and let us denote this as EA, and let us denote this electric field as EB. Now, since now consider these two triangles, that is APO, triangle APO, and triangle POB. So in these two triangles, OP is common to both the triangles. OA is equal to OB. So therefore, this AP will be equal to PB. Now, we know that the intensity of electric field due to any charge E is given by 1 by 4 pi epsilon naught. This is the formula if the charges are placed in the free space, into the magnitude of the charge divided by r square, where r is the distance between the charge and the point under consideration. So here, this, since AP is equal to PB, this AP is equal to PB, and the magnitude of both the charges are equal. Therefore, this EA will be equal to EB. That is the intensity of electric field due to these charges. The magnitude of the intensity of the electric field will be the same. However, their directions will be as indicated by these arrows. Now, we have to find the resultant of the intensity of the electric field at this point P due to these two charges. So here we will be using the parallelogram law of vector addition. Now Here this EA and EB are the two vectors, and their direction is given by the arrows as indicated in this figure. So the resultant intensity at this point P will be given by EA square plus EB square plus 2 times EA EB into cos theta, where theta is the angle between these two vectors, that is the angle between EB and EA. So let us say I am taking this angle as theta. Okay, this is the angle theta. So R will be equal to under root. Now since EA is equal to EB, so what I will be doing is I will be substituting the value of EB as EA. So this will be EA square plus 2 times, this will become EA square into cos theta. So simply it means that the resultant intensity of electric field at the point P, I am just denoting this as, let us say, RP. That is the resultant value of the intensity of electric field at the point P due to these two charges. So this will be equal to EA square plus EA square, that's 2 EA square. So 2 EA square will be common, and I will be getting in bracket 1 plus cos theta. So here the most important thing here is that we have to find the value of cos theta. So I will be now just rubbing it, and so RP, that the resultant value of the intensity of electric field at the point P is equal to 2 times EA square in bracket 1 plus cos theta. So now we have to find the value of cos theta. If this angle is theta, then this angle, that is angle APB, this will be equal to 180 minus theta. And since this is the perpendicular bisector of AB, and since OA is equal to OB, ठीक है ना, OA is equal to OB, therefore this angle, that is angle APO, will be equal to angle OPB, and this will be equal to what? 180 minus theta divided by 2. This is equal to 90 minus theta by 2. So this angle will be equal to 90 minus theta divided by 2. This angle. Now consider this triangle APO. Okay, from triangle APO, I can write that sine 90 minus theta by 2, this will be equal to perpendicular upon hypotenuse. So now for the sake of making this calculation easy, what I am doing is right now I am simply taking this OA, which is equal to OB, as A, and I will be taking this OP, which is equal to 15 centimeters. So for the time being, I am taking this length as B. So if this is A and if this is B, then AP will be equal to under root of A square plus B square. So sine theta minus 2 will be equal to this perpendicular upon hypotenuse, which will be equal to A square plus B square. Okay, right now I am not taking these values because I will be putting these values later on. So, and this is equal to cos theta. Sin 90 minus theta, sin 90 minus theta by 2 will be equal to cos theta by 2. This is equal to A upon under root A square plus B square. So in this question, the most important thing is that a lot of concepts related to basic mathematics will be utilized. So here I will be writing the value of this cos theta by 2 as A divided by under root A square plus B square. Now let us find the now cos theta by 2, we have got the value of cos theta by 2, but here it is written 1 plus cos theta. So we know that cos 2 theta is equal to cos square theta minus sin square theta, and this is also equal to 2 cos square theta minus 1, because if I substitute the value of sin square theta as 1 minus cos square theta, so I will be getting this this value. So, or we can say that cos theta will be equal to 2 times cos square theta by 2 minus 1. If here is when it is 2 theta, then you will be getting this as 2 cos square theta minus 1. So if it is theta here, then I will be getting here as theta by 2. So from here I can get the value of this 1 plus cos theta is equal to 2 cos square theta by 2. So this is an important step for getting the resultant value of the intensity of electric field. And so what I will be doing here is I will be substituting the value of 1 plus cos theta in this equation. That is, the resultant intensity of the electric field at this point P will be equal to under root 2 times EA square into 1 plus cos theta is equal to 2 cos square theta into 2 cos square theta by 2. So the resultant is equal to this. This is the 2 into 2 is 4. So the under root of 4 is 2. EA square. The under root of EA square will be equal to EA. And cos square theta by 2. So it is under root of cos square theta by 2 will be equal to cos theta by 2. So finally I have got the equation, that is the resultant intensity of electric field at the point P due to these two charges will be equal to 2 times of EA into 2 into EA into cos theta by 2. And cos theta by 2, the value of this cos theta by 2 is given here. So we have to simply now put the values, that is 2 into EA. Now EA is what? 1 by 4 pi epsilon naught, which is equal to 9 into 10 to the power 9 into Q. The magnitude of this charge is 10 into 10 to the power minus 6 divided by A square plus B square, because the value of this EA, now EA is equal to EB, and the formula for this E is equal to KQ upon R square, where R is the distance between the charge and the point under consideration. So that is equal to under root, this R is equal to basically R is equal to under root of A square plus B square. And since in the equation it is R square, so this will be equal to A square plus B square. Into cos theta, which is equal to A divided by under root of A square plus B square. Okay. So now we have to only simply solve this equation. So what I will be doing is resultant RP is equal to 2 into 9 into this A is equal to 2.5 mm. So this will be converted into meters. So this will be equal to 2.5 divided by 1000. A square plus B square under root A square plus B square, and this is 10 to the power 9, and this will become 10, this is equal to 10, 9 plus 1, 10, 10 minus 6 is equal to 4, so this is equal to 10 to the power 4, okay, and this is 2 into 9 and into 2.5, yeah, so this is the value of the resultant, and so Rp will be equal to 45. This 1000 hai, so this can go up and this will be equal to 10. So, because this will be equal to 10 to the power minus 3, so this is equal to into 10 divided by a square plus b square into under root of Now you have to find the value of a square plus b square, and then so a square plus b square, here a is equal to 2.5 mm. So this is 2.5 mm means this will be in, we have to convert it into meters. So this will be equal to 1000 and whole square. So this will be square and this will be square plus b is in 15 centimeters. So this is 15 upon 100. So this will be square and this will be square. And just take the LCM of it. This will be equal to, so this will be equal to 6.25 plus 225 0 0. So I will be getting the answer as 225 22500 plus 6.25, which is equal to 2. This is equal to, and divided by this is equal to 0.0225. Yeah, and now we have to find the under root of this a square plus b square. So the under root will be equal to 0.2, sorry, 0.225. 0.0225, which is equal to 0.15. Okay, so the finally what I am getting is the resultant Rp will be equal to, this was equal to 45, this was 45 into 10, which is equal to 450, divided by I will just remove that, divided by 0.0225 into 0.15. Now we have to only solve this value. We have, and what I can do is I will remove this decimal. So 1, 2, 3, 4, 5, 6. So 450 into 10 to the power 6 divided by 225 into 15. 3375. So this can be written as 450 hai. I will be just taking this 10 to the power 6 can be written as 10 to the power 5 into 10. So this can be equal to 4500 divided by 3. How much? 225 into 15. 3375 into 10 to the power 5. So this is equal to, now 4500 divided by 3375, 1.33. 1.33 into 10 to the power 5 newtons per coulomb. So this is the magnitude of the resultant electric field at this point P due to these two charges. So here the most important thing was the calculation of cos theta by 2. So in physics, there is in physics the involvement of basic mathematics is always there, and you will be seeing the that most of the or almost all the numerical problems involve the concepts of basic mathematics. So you all have to have a very good understanding of basic mathematics. So that was the main reason of taking up this question, in order to just show you that in physics, you all have to have a very good understanding of basic maths. So I hope you have understood the solution of this problem, this question, and in the next question I will be coming up with a different topic from the same playlist, that is electric charges in field. So till then, have a nice day. Bye.